Arcs and sectors of a circle. We might want to work out the length of an arc of a circle. To do this, consider a circle with radius r and an angle theta measured in radians at the centre of the circle. Then the angle will subtend an arc, and we've seen that when we define radians, the angle theta is defined as being the arc length divided by the radius. So if we multiply both sides of the equation by the radius, we get, when in radians, the arc length is the radius times the angle, or the arc length is r times theta. Now when working in degrees, we have the arc length is a fraction of the circumference, and the fraction is the angle theta divided by the total angle in a circle, which is 360 degrees. Now the circumference is 2 pi r, so the arc length over 2 pi r is equal to theta over 360 degrees. Now if we multiply both sides by 2 pi r, we get the arc length is equal to theta over 360 times 2 pi r, or the arc length is equal to theta degrees over 180 degrees times pi r. Now we also might be interested in the area of the sector enclosed in the angle. Now we've got that the area of the sector is also a fraction of the circle, so the area of the sector over the area of the circle is equal to the fraction of the angle compared to the full circle. Now in radians, a full circle is 2 pi, so the area of the sector over the area of the circle is theta over 2 pi, and the area of a circle is pi r squared, so the area of the sector is theta times pi r squared over 2 pi, or the area of the sector is a half times theta times r squared. The area of the sector is a half the angle times the radius squared. Now in degrees we have the same fraction. The area of the sector over the area of the circle is equal to theta degrees over the total angle in a circle, which is 360 degrees. So the area of a sector is theta over 360 degrees times pi r squared. Now the following is an exercise. You can pause the video at this point and have a go at the questions yourself. Then you can restart the video and I'll go through the answers. Okay, let's have a look at the answers. Well, in the first question we have to find the arc length and the area of each of the following sectors. In part 1 we're told the radius is 5 centimeters and the angle is 3 radians. Now, the arc length is theta r, the angle times the radius, and the sector area is a half times theta r squared, or a half times the angle times the radius squared. So the arc length in the first one is 3 times 5, which is 15 centimeters, and the sector area is a half times the angle times the radius squared, a half times 3 times 5 squared, which is 37.5 square centimeters. In part 2 we're given that the radius is 12 centimeters and the angle is 1.5 radians. Now the arc length is the angle times the radius, which is 1.5 times 12, which is 18 centimeters, and the sector area is a half times the angle times the radius squared, a half times 1.5 times 12 squared, which is 108 square centimeters. In part 3 we're told the radius is 4.5 centimeters and the angle is 2 pi over 3 radians. So the arc length is 2 pi over 3 times 4.5, which works out to be 9.4247, which rounded off gives 9.42 centimeters. And the sector area is a half times 2 pi over 3 times 12 squared. So that's 21.2057, or 21.2 square centimeters when rounded off. In part 4 we're told the radius is 5 centimetres and the angle is 5 pi over 6 radians. So the arc length is the angle times the radius, 5 pi over 6 times 5, which is 13.089, which rounds off to 13.1 centimetres. And the sector area is a half times the angle times the radius squared, so it's a half times 5 pi over 6 times 5 squared, which works out to be 32.7249, which rounds off to 32.7 square centimetres. In question 2, we're given a diagram with a circle. The angle ACB is equal to 2.4 radians, and the radius is 8 centimetres. In part 1, we're asked to find the length AB. Well, to do this, we need to draw the diagram again. We have AC is equal to 8 centimetres. Now we can draw a perpendicular CD to AB, in which case D will be the midpoint of AB, and the angle ACD will equal a half the angle ACB. So the angle ACD will equal 1.2 radians. Now, in the triangle ACD, we've got the side AD is the opposite, and the side AC is the hypotenuse. Now we've got the sine of ACD is the opposite over the hypotenuse. So since we're working in radians, the sine of 1.2 radians is equal to AD over 8. In other words, 8 times sine of 1.2 radians is equal to AD. Now to work this out, we must make sure that we've got the calculator in radian mode, not degree mode. In which case we get AD is equal to 7.4563 centimetres. AB is twice AD, so the side AB is 14.9126 centimetres, and if we round that off, we get AB is equal to 14.9 centimetres. Now in part 2, we're asked to find the arc length of the yellow segment. Now the arc length AB is equal to theta r, or the angle times the radius, which is 2.4 times 8, which is equal to 19.2. So the arc length AB is 19.2 centimetres. In part 3, we're asked to work out the area of the triangle ABC. Now we're using the area of a triangle is a half A times B times the sine of C. Now the area of the triangle is a half times 8 times 8 times the sine of 2.4 radians. Now that works out to be 21.6148. And so the area of the triangle ABC is equal to 21.6 square centimetres. Now in part 4, we're asked to find the area of the yellow segment. Now to find the area of the yellow segment, we must find the area of the sector CAB and subtract the area of the triangle ABC. Now the area of the sector is a half times theta times r squared. It's a half times the angle times the radius squared. So it's a half times 2.4 radians times 8 squared, which is 76.8. Now the area of the shaded region is equal to the area of the sector, which is 76.8, take away the area of the triangle, which is 21.6. And that gives us an area of 55.2, and so the area of the shaded region is 55.2 square centimetres. Now in question 3, we're given a diagram and we're told that in the diagram AD and BD are tangents to the circle, radius 7 centimetres. We're also told that the angle ACB is equal to 1.5 radians, and we have to calculate the area of the shaded region. Well, let's draw a larger diagram. Now we have the area of the shaded region is equal to the area of the quadrilateral ADBC minus the area of the sector ACB. If we join C and D, we get the angle ACD is equal to 0.75 radians. Now we've also got that CAD is a right angle, because the tangent is always at right angles to the radius. Now, if we look at the angle 0.75 radians, then the side AC is the adjacent and the side AD is the opposite. Now the tangent of the angle is the opposite over the adjacent, and so AD over AC is equal to the tangent of 0.75 radians. So AD is equal to 7 times the tangent of 0.75, which works out to be 6.5212. The area of the triangle CAD is equal to half the base times the height, so that's a half of 6.5212 times 7, which is 22.824. The area of the quadrilateral ADBC is twice that, so it's 45.648. Now if we look at the area of the sector ACD, that's equal to a half times the angle times the radius squared. So it's a half times 1.5 times 7 squared, which is 36.75. So the shaded area is the area of the quadrilateral minus the area of the sector, 45.648 minus 36.75, which equals 8.898. And so rounding it off, we have the shaded area is 8.90 square centimetres.